New high-performance Lipo's for 2018 are starting to come out, and I've got a batch here I'm going to test from Intellect, and I've got some Nosram ones which are identical to the LRP ones, which are blue. These are for 2018. I'm going to see if they've improved the performance or whether they're the same as last year's one. Now, I've tested a lot of batches, and I'll test more when they become available, but there's enough here to do at the moment. I've recorded all the results from previous tests that I've done of all sorts of batteries and rated them. How I do it briefly is I charge them up. Well, actually they're cycled first. I discharge, cycle them, and then they're discharged to make sure that they all are going to perform at the optimum. And then I make sure they're all at ambient temperature. Then I'll charge them up. Previously I've charged at 10 amps. This time I'm going to charge at 20 amps just to speed it up a bit to 8.40 volts. These are all 7.6 volts high voltage cells that can be charged a bit higher, but you can charge them to 8.4 volts and they will perform just the same as a normal LiPo. Anyway, charge them to 8.40 volts on this iCharger over here, 20 amps. Take them straight off and put them straight onto a discharger without delay, 0.2 ohms resistance, and record the voltage from start to finish at certain milliamp points so that you can compare them exactly. Milliamp points I normally use are 600, 1 amp, etc., 1.5 ampere hour, and record the voltage that I'm getting at that milliamp reading. The ones that hold up the highest voltage under load are going to perform the best in a car and give you the best performance. I prepared a chart here of the batteries I'm going to do, and what I'll do is work through them one by one. Now, I've also got last year's one of them I'm going to retest to make sure nothing has changed, especially at the 20 amp charge rate, and make sure I compare the results with that one as well. Just before I start, we've got a bit of information. Intellect, the new batches, 2018. New black case. Well, they have improved the appearance. This is much nicer. This was done previously on some batteries like Reedy, etc., so that when you put the tape around the top it doesn't rip the label off. So they've taken a while to get around to doing that. The Nosram LRP already did that. Anyway, new black case design, new cool looking labelling, yeah. Silicon graphene. Well, silicon graphene has been around as a name on batteries for a while. Last year and the year before, Turnigy used it some time back, and this one says graphene 2 on it, and the new one's still on the IP say silicon graphene. HV3, well, a high voltage 3. They started off a couple of years ago with their first high voltage cell. Then they brought out the last year. They call these HV2. It's on the spec, the HV2. They write LIHV, lithium high voltage, on the big writing there. So they're now up to HV3 spec. Gives great run times. They didn't say greater, so great run times and power with improved cycle times and safety, whatever all that means. 2 to 3% weight reduction for the majority of packs with greater performance. Well, we're going to find out if that's true. On their actual, a bit more blurb here from them. Basically says the same. LIHV technology has the ability to be charged to 4.35 volts per cell, but normal racing regulations allows up to 4.20 volts. Which is what we're going to use when I charge these up. Ratings 120C, but they were 120C last year, still 120C. Capacity, this is a 6000, they haven't changed the capacity. 5mm tubes as before. Size 22.5. I'll just double check the sizes, see if that's right. And the weight, they give weights of 270 grams. I'm going to weigh them anyway. Approved. And that's the IP ones. Now the Nosram ones, they say a lot more on theirs for the new specs for 2018. They call it the graphene 2-cell. They call it the next step in graphene development. More power, weight optimized, high voltage, etc. Improved lifetime. Significantly improved lifetime when charged to 4.20 volts per cell. That's what we're going to do. 5mm connectors. What else they say? 3C charge current. Well, that'd be 3 times 6.4. It's nearly 20 amps. IP don't actually say what you can charge them at. Some regulations say if there's not, you have to charge them at 1C if it doesn't say, which would only be 6 amps, which would be rather annoying. Extremely fast, it's safe to recharge, approved. 120C again. This C rating is a bit confusing because there's normally 2 ratings given, a burst and a constant. Some manufacturers quote very high C ratings. Anyway, I would say 120C. Both of these are going to be 120C as was last year. No memory effect, well that's normal. Long lifetime, quality. They call this one the P5HVTC LCG stock spec graphene 2. Quite a long name. Maximum power, low center of gravity, low weight. 274 grams, they say, 22.5mm thick. I can check that. Anyway, sorry about all the blurb, but it's interesting to compare. I've already weighed these batteries, and obviously the big ones, the 8400s weigh the most. The Intellect is 326 gram, and the Nosram, which they call an 8000, is 332 grams. I've re-weighed last year's one, which was 333 grams, which I measured when I tested it originally. It still is. So 330, 332, 326, those big ones are very similar in weight. 6000 milliamp one, 266 grams for the Intellect, and they call theirs a 6400 Nosram, 276 grams, so similar. There's a couple of others I'm going to test from Intellect. I tested these batteries last year and they didn't really come up to the performance I was expecting, and one of them is this 5200. Now the rating is still 120C, same as the others, but last year when I tested it I didn't find it held up the voltage at all. 244 grams, so it's pretty lightweight. There's another interesting battery here, is this one. This sort of shorty. If you look at it, it's a 6000 milliamps, exactly the same as this one. 6000, 6000. 120C, 120C. So the differences are, there's a tiny bit, this one's a tiny bit thicker, but you wouldn't expect that you could get the same performance out of this battery as this one. Otherwise, what would be the point of using this heavy one? Because if you look at the weight, 266 grams for the long one, and the short one is 217 grams. Both 6000 milliamps, both 120C. So it's going to be interesting to see how they actually deliver the power, whether they're the same or whether this one will hold up the voltage much higher. So that's the preamble. I've got to do all the charging and discharging now, which takes ages, but as I said, I'll do it the same for every one so that there's no variation. Charge them up, put them straight on discharge, read the values. The IP5200's just finished charging from a flat. Managed to get 4,643 milliamps in. Those are the IR readings, 2.2, 2.1, and it's dropped back a fraction. It's just come off, so charged to 4.2 each one. Now I'm just gonna, you can check the temperature. It's ambient about 20.6. So I'm going to go and put it on the discharger. Right, from the charger to the discharger, there's the display ready to go, which I can read off all the results. You've got the amps it's going to draw, and then the milliamp reading at the bottom there. Here we go. Instant voltage is 7.96. And it's dropped to 7.89. Then I measure it at 600 milliamps, which will represent the first couple of laps in a race. See the first couple of laps, you want to go as quick as possible, so you want the voltage to remain as high as possible. After 600 milliamps, it's at 400 at the moment. I'll measure it at 1 ampere hour, 1.5, and so on. And I'll record it on the chart, and then I'll show you the chart at the end. So it's just coming up to 600 milliamps now, and it's at 7.76 volts. So it's maintained, just dropped, say we say 7.75 or 7.76, and it's dropped quite quickly at that point to 7.70. 1 ampere hour, it's 7.57. The 5200 battery, we would hope it would get near 5200 milliamps. I'm going to take it off when it hits 6.0. As you can see, it's already at 4.7, 4700 milliamps. 5200 is normally measured at the higher voltage, at charge voltage, so we expect it to be a little less. It's coming down now, 6.2. I'm going to take it off at 6.0, which is there, and it made 4,840. Disconnect that. Let's pull back a bit. There it is. You can measure the temperature. It's about 31, 32. It's around about 32, 33 degrees C. So that was the 5200. As I said, that is if you charge it to the 7.6 volts. We've only charged at 7.4, so you get slightly less capacity. I've recorded all the voltages that it maintained from start to finish. And I finished testing the batch of batteries for 2018, some IPs and Nosram 2S high-performance batteries, and recorded all the results on this chart for discharge, seeing how the voltages hold up under heavy loads. I also got the results from last year, so we can compare this year's new ones and see if they've improved or any difference at all to last year's. I can also compare the different batteries and see which one's better or worse, and also I'm going to have a look at a couple of batteries of the same capacity and see what difference is between them. So first of all, it can be a bit confusing, so looking at the table first off, I recorded these are the batteries I've tested, and looked at the weight. Obviously the bigger ones, the 8400 for instance, is going to be much heavier. Then one of the smaller ones, like the 5200, only weighed 244 grams. Anyway, I've got the new Intellect 8400 and the Nosram 8000, and I also tested last year's 8400. So those three, we can compare them. Now, before I do that, I'm going to have a look at these two 6000 milliamp hour ones, which I was very interested, from Intellect. They both got the same rating, 6120C, but they're slightly different size and different weights. This is only 266 grams and this is 217 grams. We've got them here. They're both 6120C. This one's slightly thicker, but quite a difference. So are they going to perform exactly the same? Now on this chart, the voltages that we're looking at that are really important are when you start the race, the battery's going to drop straight away as you power off drawing current, and so it's for the first few laps of the race you want to have a good voltage from the LiPo. So looking at this column here, the instant drop, the ones that hold up the highest voltage are going to give you the most performance, everything else being equal. And then after about 600 milliamp hours, after a couple of laps, you still want to be maintaining the fastest and highest voltage you can. As the race goes on, for a 17.5, towards the end of the race, say about 2000 milliamp hours, you want to hold the highest voltage to maintain the speed at the end of the race, and up to say 3000 milliamp hours for let's say a 13.5. Again, those are the columns we want to look at. There's quite a number of confusing results here, so we divide it up into the different weights. Now you notice that the biggest battery gives the best voltage. There's no doubt at all that the bigger the battery, the better it's going to hold up the voltage under load. Looking at the 8400, the start 7.96. If you go down here to the Nosram, also 796. And last year's Intellect 84796. At the 1 ampere hour point, 7.76, 776, the 3, 737, 73737. So these batteries are virtually, well, they give identical results. They could be the same battery. And the one from last year, the IP, and one to the new IP, right to the end, they're exactly the same. At 7,000 milliamp hours, they've still got 698. And then they finish off about 7,500, near enough. They're the same. It's like they're the same battery. Slight difference in temperature on the case, but you will get a slight variation. On the charge, on the IR, on the Intellect, there was a difference. The one from last year is about 1.7 to 2 milliohms. The Nosram was 1.717, and the new Intellect was 1714. That's an indication of how good the battery is, but it's the voltage under load that is more important than any IR reading. So far, those three batteries seem to be identical. Now, what about the weight? Last year, the Intellect was 333 grams. Now, according to their blurb, they have lowered the weight on their batteries, and we find that it's 326 grams now. So they have actually shaved 7 grams off. The Nosram, still 332 grams, same as last year's one. These could be the same batteries. You get a variation. So this year's battery last year's battery, there's no difference, in my opinion, on the big ones. Cost-wise, in this country, the Intellect still costs the same, recommended £70. The Nosram is £90, so there doesn't seem to be any point in buying that one when the Intellect one gives exactly the same performance for less money. That's those. Now, a very interesting two were these 6000s from Intellect, and we're going to have a look at them now. They're these two here. The Intellect 6000, the Intellect 6000. Well, this is the shorter one. Checking the weight. 266 grams against 217 grams. Start of discharge 796, drops straight to 789, but after 600 milliamps, first couple of laps in the race, the smaller one is started to drop behind. At 2000 milliamps, it's still dropped behind. 3000 milliamps, it's still lower, and in the end, strangely enough, that gives slightly less capacity, about 5,400, 5,200, and the smaller one, noticeably higher temperature. Well, it's a smaller package, the heat's more concentrated in the package, so you'd probably expect the heat to increase on a smaller case, and the other one's got a bigger surface area. Milliohms, on charge it was 1.8 and 2 and 2323, so it appears to be the smaller one seems to have a higher internal resistance. So that's those two. So they're not identical in performance. The bigger one does actually hold up the voltage better and will give better performance. But there's another battery on this list, the 5200, which is a normal length but very thin, 22 millimeters, this opposed to well, this is 22 millimeters thick. This one is 24.7. The 5200 and the 6000 short gave identical results under load all the way through to the end. The weights are slightly different, with the 5200 weighing 244 grams and this one only weighing 217 grams. If you wanted to use these lightweight batteries, if you use this one, you can also position it backwards and forwards in the car to give you your weight transfer where you want it in the car. This one is a standard stick length, so it's basically fixed in the car in that position. Also, this one is cheaper than this one, so it's slightly thicker, but that's not much of a problem. So that was quite an interesting comparison of those two. Now, the only other one to look at was comparing the Nosram, say 6400, to the Intellect. The Intellect weighs 266 grams, the Nosram 276 grams. Which one is better? You've got the Nosram one is the red one. That's a 6.4, as opposed to the IP one. You notice that the plus and minuses are the opposite way round on Nosram to IP. There's no through holes on that one, but there are three through holes on this one with little inserts that you can switch the other side if you want to use both and want to mix your wiring up from the speedo. The only problem is you've got the balance port on that side, if you put these stoppers in that side, you're going to have to wrap the balance wire around it if you're doing balance charging. Anyway, besides that, they it's identical size. Which one is better? That's the 6000 of the Intellect, and that's the 64. At 1 ampere hour, 7.7, 7.63. So the Nosram 2 amps, 744, 744, and at 3, 731, 731. And right at the end, the Nosram holds the voltage a bit. So it's a bit variable. It's a little bit better at the start once it gets going. In the middle it's the same. And at the end the Nosram is just, if you're going to 4000 milliamps or higher, Nosram's slightly better. Cost wise, £70, £70. So I'd say if you had to choose, although there's hardly anything in it, the Nosram might just give you a fraction better performance than the other one. The IR's 182, Nosram was 2.22, but it's the voltage that's important. Conclusion is that Intellect, the IPs, have reduced the weight fractionally on their cells without any increase in actual performance. Of course, they might last longer, they might not swell up anymore, they might have a very long life without losing any performance. I haven't been able to test that. The price hasn't changed, so you might as well buy the new one over the old one. If the old one's still available, then it still performs exactly the same as the new one, just a slight difference, slight reduction in weight. There's been no reduction in weight that I can see on the Nosrams. This one, the 6400, it now weighs 276 grams, and last year on this chart there it weighed 277 grams. So it could be the same battery, just with a different sticker on it. Again, it might last longer, it might have a much longer life. So far those are the tests I've done on this first batch of batteries for 2018. There's a lot more batteries around. If I can get hold of them, I'll do tests on them as well, and see if any of them can beat the performance. If you want absolute best performance and you don't mind the weight, buy the big Intellect 8400. Good price, holds the best voltage right through, and same as last year. The Nosram one, same, but costs more, and it weighs a little bit more.